Okay, the purpose of this video is to do a quick overview of the chain rule and see how it applies to our latest function, the e to the x function that we've been exploring. But just as a refresher course about the chain rule, the basis of the chain rule is we use it when we work with composite functions. For example, we're going to take this g of x function, which is a quadratic x squared plus 5x, and we are going to compose it as an input into a new function. For example, if f of x was 1 over x, and we wanted f of g of x, that would be 1 over x squared plus 5x. In the case of x cubed, if we put f of g of x, then we're going to take g of x and substitute that in there. And if f of x is the square root of x, then f of g of x is the square root of x squared plus 5x. So we put that right in there. And if we have f of x equals e to the x, then composite would say the exponent is now quadratic in nature. So it's e to the x squared plus 5x. So in any situation where you see a composite function, that is one function that's made from inputting another function inside of it, is essentially going to be a candidate for the chain rule when we're doing calculus. So in this first case, for example, if I wanted to differentiate y equals x cubed, I simply remember to use the power rule. I bring down the 3, drop the power by 1. Case closed. So some people make the mistake of differentiating x squared plus 5x quantity cubed by just using the power rule. They bring down the 3, they drop the power by 1, and they keep everything the way it was on the inside. The problem is they forgot the chain rule. The chain rule says we need to multiply by the derivative of the inside function. So don't forget, add your derivative. Another situation. Some people, when they differentiate y equals the square root of x, like to make it in power form. So you make that to the 1/2 power, which means we multiply by 1/2, we drop the power by 1, and when we simplify, we get 1 over 2 times the square root of x. Same deal then, when we're taking the square root of x squared plus 5x, we would get 1 over 2 times the square root of x squared plus 5x. Most people will get that far, but some will forget, multiply by the derivative of x squared plus 5x. So that is a numerator number, and it goes in front, or sorry, it goes in on top. We're going to differentiate y equals 1 over x. We could use the power rule and get negative 1 times x to the negative 2, also known as negative 1 over x squared. So when we're working with a composite, 1 over x squared plus 5x, we do the negative, we do the square of the denominator, but we have to remember, multiply by the derivative of x squared plus 5x. That's the chain rule. And finally, we differentiate e to the x, we get e to the x. That's the best one. It's hard to screw up. But if I have e to the x squared plus 5x, then the derivative is e to the x squared plus 5x. But we have to remember, multiply by the derivative of x squared plus 5x. So that's the chain rule in a nutshell. Here you're going to see 3 different examples of applying the chain rule. First, identify there is a composite function. We do the power rule to the outside, and then we take the derivative of the inside. And the derivative of 3x plus 1 is 3, so that's what we got out in the side. And then we multiply the 2 times the 3 and get 6 times 3x plus 1. Here's another example. We have the square root of a quadratic function. So we do the power rule on the outside. So we multiply by half, drop the power by 1, and then we take the derivative of the inside. That's going to be 26x minus 5. So the rest is just algebra simplification. The last example is a 30th power. We have a a 5th degree polynomial to the 30th power. If we want to take the derivative using the chain rule, we're going to take the power rule, 30 times everything on the inside to the 29th power, times the derivative of the inside stuff, which is going to be negative 4 plus 35x to the 4th. So there again, we could see the chain rule. We take the derivative of the outside, leave everything else alone, and then we take the derivative of the inside, and the rest is cosmetics cleanup. Hope that's helpful.